Imagine a world where we can rearrange atoms one by one, where we don't just study matter, but design it. A world where we can make computers the size of a dust particle, materials stronger than steel yet lighter than air, and devices that heal the body from within. Welcome to the incredible frontier of nanotechnology and quantum materials. You're watching the Learning Studio, and in today's episode from our physics playlist, we'll uncover how the tiniest building blocks of matter are shaping the next century of science and technology. You can explore the entire physics playlist by clicking the link below in the description. This topic belongs to our section Matter, Materials, and the Rise of Technology, where we explore how understanding the smallest things gives us the power to create the biggest innovations. The world at the nanoscale. Let's begin by shrinking our view. A nanometer is just 1/1,000,000th of a meter, about 100,000 times smaller than the width of a human hair. At this scale, the ordinary rules of physics begin to blur, and quantum effects start to dominate. In the macro world, a material's properties depend on its composition, like steel's strength or copper's conductivity. But at the nanoscale, even changing the size or shape of a particle can completely alter its behavior. Gold, for example, which shines yellow in bulk, glows red or purple when broken into nanoparticles. This is where nanotechnology begins, the art and science of controlling matter at atomic and molecular scales to achieve properties nature never intended. Quantum materials, nature's hidden superpowers. Now imagine materials that don't just behave differently, they obey entirely new laws. These are quantum materials, substances whose properties arise from quantum mechanics itself. In these materials, electrons act in astonishing ways. They may move collectively, as if choreographed by an invisible force, flow with zero resistance like in superconductors, or even split into fractions of themselves, as seen in topological insulators. Quantum materials include graphene, a single layer of carbon atoms that's stronger than steel, yet flexible and transparent. Topological insulators, materials that conduct electricity on their surface but remain insulators inside. Quantum dots, tiny crystals that emit light so pure and controlled that they're now used in the most advanced display technologies. These materials are redefining what's possible, not only in physics, but in electronics, computing, energy, and medicine. Nanotechnology in action, the next industrial revolution. Nanotechnology isn't just theoretical, it's already transforming industries. In medicine, nanoparticles deliver drugs directly to cancer cells, minimizing side effects. In energy, nanostructured solar panels capture more sunlight with higher efficiency. In electronics, nanotransistors now pack billions onto a single microchip, powering the AI systems of today. And in materials science, nanocoatings make fabrics waterproof, self-cleaning, and even antibacterial. At the center of it all is the principle that small changes at the atomic scale lead to big revolutions at the human scale. AI meets nanoscience. As we explore deeper into this microscopic realm, the complexity skyrockets. That's where artificial intelligence steps in. AI and machine learning models are now helping scientists predict how atoms will arrange themselves, how new nanomaterials will behave, and how quantum effects will influence their properties. This collaboration between AI and physics is creating a new research paradigm, one where simulations replace guesswork, and discoveries happen at digital speed. For example, AI-driven algorithms can design quantum materials with properties suited for quantum computing or super-efficient batteries, revolutionizing both information technology and energy sustainability. From atoms to AI, the future of physics and innovation. The beauty of nanotechnology and quantum materials is that they represent both extremes of physics, the smallest and the most powerful. At this intersection, Humanity is learning to manipulate matter with precision that rivals nature itself. The future that lies ahead includes quantum transistors smaller than a single molecule, nanorobots capable of repairing cells inside the human body, quantum metamaterials that can bend light, sound, and even time in ways we can barely imagine. This isn't just evolution, it's the reinvention of material reality. This is the Learning Studio, and this was our episode on nanotechnology and quantum materials. If you're fascinated by how the smallest scales of nature are giving birth to the biggest technologies, make sure to subscribe, like, and check out the physics playlist linked below. In our next episode, we'll explore condensed matter physics and superconductivity, where matter enters extraordinary states that challenge resistance itself and unlock the dream of lossless energy. Because in physics, sometimes the most powerful forces are hidden in the smallest places, waiting for us to discover them.